Hello friends, myself Professor Doshi VM from ADSUL'S Technical Campus, CHAS, Ahmednagar. Today's lecture we have to discuss about a voltage regulation of three-phase generator. So the voltage regulation is defined as the change in terminal voltage of alternator when the load is zero divided by a rated terminal voltage at a constant speed and excitation. It's called as a voltage regulation. And the formula for the voltage regulation is that E0 minus V upon V, that is percent voltage regulation equals to E0 minus V upon V into 100. Here the capital E0 is the terminal voltage when the load is thrown off, and capital V is the terminal voltage under the loaded condition. So the main reason to find out the voltage regulation is that it shows the performance of the synchronous generator. So to find out the voltage regulation, we have to find out the testing of synchronous machine. These tests are conducted to demonstrate that the machine gives the required parameters or the performance. So testing of synchronous generator. Here is a list of testing of synchronous generator. Uh, the main method of finding out the voltage regulation. The voltage regulation is determined only by two methods. First is direct loading method, and another is the indirect loading method. In indirect loading method are divided into three types. First is synchronous impedance method. It's called EMF method, and second is ampere turn method. It's called MMF method or the rheostatic method, and the third is zero power factor method. That is a Portier triangle method. Okay, so this here a list is given for a various testing of synchronous generator. First is the open circuit test, no load test. It is also a indirect loading method test. Second is short circuit test. It is also indirect loading method test. Then zero power factor characteristic test and loss measurement test. Then temperature rise test. After that, full load. This temperature rise test divided into two types. First is by full load, zero power factor overexcited run, and second is by equivalent heat run. Then number 5 is overspeed test, and number 6 is high voltage test. After that, 7 number is insulation resistance test, and number 8 is waveform interface gap length, balance vibration bearing current, and magnetic symmetry, etc. 9 number is measurement of DC resistance of armature and field winding, and the last one is the dielectric test. So testing of generator, there are mainly two tests. First is commissioning test. In these, number one is insulation resistance test. Second is measurement of DC resistance of armature and field winding. Third is waveform interface test, and number four is line charging capacity. Uh, in case of performance test, first is slip ring test. Second is sudden short circuit test. Third is determination of transient and subtransient parameters. Number fourth is the determination of sequence impedance. Number fifth is the separation of losses, and the last one is the temperature rise test and retardation test. So the testing of synchronous generator, when the machine is in the factory, there are some factory tests factory tests are occurred on the synchronous generator. Number first is gap length, two is magnetic symmetry, third is balancing vibration, fourth is bearing performance, fifth is open circuit test, that is OC test. After that, SC test, then ZPF test. Next, OST means overspeed test. After that, 9 number is high voltage test, that is HV test, and the 10th number is waveform interface test, gap length, balance vibration, bearing current, magnetic symmetry, etc. And the last one is 11th number is dielectric test. So the testing of synchronous motor, in case of which tests are occurred in case of generator, we have observed already. After that, we have to observe which tests occur on the synchronous motor. The first test is measurement of DC resistance of parameter and field winding. Second is dielectric test on armature and field winding. Then next is mechanical balancing test. Then fourth number is temperature rise test. Fifth is overspeed test. Sixth is harmonic analysis. Seventh is telephonic interfacing test. Eight is SC test. Nine is retardation and time constant. 10th is speed torque characteristics. 11 is efficiency calculation. 12 is bearing insulation test. 13 is direction of rotation. 14th is current balance on load, and the last one is commissioning test. These are the tests which are occurred on the synchronous motors. So now we have to perform an open circuit test to find out the efficiency and the regulation of the synchronous generator. Okay, the open circuit test and short circuit test are done on a synchronous machine to find out the parameters of the synchronous generator, mainly synchronous impedance of large machine, to calculate the voltage regulation. Okay, first of all, we have to calculate the open circuit test. Here alternator is run on rated synchronous speed and the load terminals are kept open, that is no load is connected to the alternator. Next, the field current is set at 0. This condition is called as open circuit test. Okay, then the field current is slowly increased in step and the terminal voltage E is measured at each step. The excitation current is increased to get 25% more than the rated voltage of the alternator. Graph is plotted for open circuit test between the open circuit test voltage E and the field excitation current IF. This curve is called as the open circuit characteristics OCC. That here I show you a OCC curve. OCC curve means graph is plotted for open circuit test between open circuit test voltage E and field excitation current IF. Okay, this curve is called as open circuit test OCC. It takes the shape of normal magnetization curve. The extended linear portion of the OCC is called as the air gap line. This is the air gap line. This air gap line means the extended linear portion of OCC. Okay. Next is, from the curve we know that because of the saturation in iron parts of machine, the no load generator voltage E does not increase in the same portion as that increase in field current. Okay. So this is the open circuit test. In the open circuit test, the alternator is run at rated synchronous speed and the load terminals are kept open. So in the open circuit test, we have to keep the open circuit terminals, we have to keep open in case of the open circuit test, and the field current is set at 0. This condition we called as the open circuit test. Next is short circuit test. The armature current are shorted through 3 armatures. Before starting this test, the field current should first decreases to 0 and then start the alternator. Run the alternator at a synchronous speed, increase the field current slowly in step and measure the armature current at each steps. The field current can be increased to get armature current up to the 150% of the rated value. Note down the field current if the average of the 3 ammeter reading at each step. Draw a graph is between the armature current IA and field current IF. The curve obtained is called as a short circuit characteristics SCC. Okay, we have to shorten the 3 phases in case of the short circuit test. Before starting this test, the field current should be first decreases to 0 and then start the alternator. Run the alternator at a synchronous speed increase the field current slowly in step and measure the armature current at each step. The field current can be increased to get armature current up to the 150% of the rated value. So for a short circuit test and open circuit test, we have to calculate the ZS. The open circuit characteristics OCC and the short circuit characteristics SCC are plotted on the same graph. Then calculate the value of ISC and field current that gives the rated alternator voltage per phase. The synchronous impedance ZS will equal to the ratio of open circuit voltage to the short circuit current at the field current, which provides the rated EMF per phase. So we can calculate the ZS by using the formula open circuit voltage per phase upon short circuit armature current. For the same value of field current, the synchronous reactance is called as XS equals to under root of ZS square minus RA square. So for that, consider the IF equals to OA, that the produces rated armature voltage per phase. Then the corresponding to this field current, the open circuit voltage is AB. That means the ZS equals to AB upon AC. So the short circuit ratio of synchronous machine is defined as the ratio of field current IFOC required to obtain a rated open circuit voltage to the field current ISC required to obtain a rated sustained short circuit current when the running at rated speed. Therefore, SCR equals to IFOC upon IFSC. The short circuit ratio is obtained from the data of no load test and sustained short circuit test conducted on the machine. So now we have to observe on the DC test. In this method, the alternator is star connected with the DC field winding open as shown. That means the purpose of DC test is to determine the RA available, the variable DC voltage source is connected between the two stator terminals. It gives the DC resistance between each pair of the terminal either by using a ammeter voltmeter method or by using the Wheaton's bridge. A DC source is adjusted to provide approximately rated stator current, and the resistance between the two stator lead is determined from the voltmeter and ammeter reading. RDC equals to VDC upon IDC. The average of three sets of resistance RT is taken for the calculation. The value of RT is divided by 2 to obtain the value of DC resistance per phase. As the effective DC resistance is much larger than the DC resistance due to the skin effect, therefore the effective AC resistance per phase is calculated simply by multiplying the DC resistance by a factor of 1.20 to the 1.75. A typical value is used for the calculation is 1.25. If the stator Y connected, the per phase stator resistance is Ra equals to RDC upon 2. If the stator is a delta connected, the per phase stator resistance is Ra equals to 3 upon 2 RDC. So by this kind we can calculate the efficiency and regulation of the synchronous machine to find out the exact performance of the synchronous machine. So there are some significance of short circuit test. So the first significance is low value of SCR XS increases and IAXS drop is increased, and the second is low value of SCR indicates small air gap and poor regulation due to the large IAXS drop, and the third is synchronous power is inversely proportional to the XC and lead power is stability. Okay. So voltage regulation of synchronous generator is defined the is define the rise in voltage at the terminal when the load is reduced from no load rated value to zero speed and the field current remain constant. It depends upon the power factor of the load. For unity and lagging power factor, there is always a voltage drop with the increase of load, but for loading power factor, the full load voltage regulation is 0. The voltage regulation is given as per unit voltage regulation is mod of E minus mod of V upon mod of V. Per voltage regulation mod of E minus mod of V upon mod of V into 100, where E is generated voltage per phase and the V is rated terminal voltage per phase. For both full load and no load condition, at a lagging power factor, the regulation is positive, while at power leading factor, the voltage rises with the increase of load and the regulation is negative. So methods used to calculate the voltage regulation of an alternator is direct loading method, synchronous impedance method, ampere turn method or MMF method, zero power factor method or Pottier triangle method as a modified from MMF method, and the last is two reaction theory methods. Okay, this is all of about the testing of the synchronous machine. So by using this test, we can find out the exact performance of synchronous machine, and the synchronous machine performance is very necessary for all others applications. Okay, I hope you understand this topic. Thank you.